AI models and autonomous agents constantly scrape the open web, pulling in massive volumes of digital content to feed their training models and responses. When an agent executes a tool call for Retrieval Augmented Generation, or RAG, it operates on a strict hot path. To maintain conversational fluidity with a user, that data retrieval operation needs to complete in under 30 milliseconds. At the same time, the unit economics of these individual data pulls are microscopic. We are looking at fractions of a cent per retrieval to compensate the original creator of that content. This creates an engineering paradox. If you try to route a fraction of a cent transaction through traditional synchronous API paywalls, the fixed processing fees wipe out the creator's revenue. Furthermore, the database rights required to update the financial ledger introduce hundreds of milliseconds of network delay, breaking the AI's hot path entirely. Solving this latency problem requires an architecture that completely separates the act of delivering the requested data from the mechanics of updating the financial ledger. The blueprint for this separation is the Metastamp v3 architecture, which is currently undergoing USPTO provisional patent review to establish its formal priority date. This excerpt from the USPTO electronic payment receipt details the provisions for international application procedures and national stage entries under 35 U.S.C. 371. The documentation includes 3 distinct patents, labeled A, B, and C, defining the architecture's discovery and redirection layer. While all 3 patents detail the ingestion workflow, the core engineering solution to the latency problem is the fire and forget micrometering logic detailed in Patent C. Together, these legal filings map out a standardized, decentralized mechanism to bridge the gap between public web content and licensed, metered AI data retrieval. The process begins when an AI crawler attempts to directly scrape a protected URL on a creator's public web domain. Instead of serving standard HTML content or a generic access denied error, the server detects the crawler and returns an HTTP 402 payment required status code, coupled with a custom header pointing to an XMCP license-endpoint. This instructs the crawler to abandon the scrape and redirects it to a specialized Model Context Protocol registry node where the data can be legally accessed. Once redirected, the crawler encounters an authentication middleware layer governed by a connection equals acceptance protocol. When the AI agent provides its unique error token, the system instantly logs the connection and generates a cryptographic record. This record binds the agent to the current version of the content licensing terms automatically. This same middleware leverages an in-memory Redis data store to enforce strict daily quota limits before any data retrieval tools are permitted to execute. By making the technical act of connecting synonymous with signing a legal agreement, the system bypasses the need for manual, centralized business development negotiations entirely. With the agreement validated, the authenticated agent invokes a JSON RPC tool call to retrieve a specific machine-readable unit of content called a pocket. To meet the severe latency requirements, the system uses a cache-first strategy. It interrogates a Redis data store to locate a pre-indexed snapshot of the content, which completes in approximately 1 millisecond. This is where the architecture splits. Right before sending the content back, the server schedules a background metering task on its event loop using Python's asynchronio.createTask command. The server does not wait for this background accounting process to finish. The data payload immediately fires back to the requesting agent, while heavy financial ledger updates detach and execute independently in the background. That instant response contains the structured content snapshot alongside a cryptographic license block confirming the agreed-upon pull price. This fire and forget execution ensures the AI's retrieval hot path stays under 30 milliseconds, no matter how complex the resulting financial calculations become. Meanwhile, that isolated background task begins processing a strict 4-stage financial pipeline. Stage 1 writes an audit record to the database, permanently logging the transaction. Stage 2 uses an atomic increment operation to update the pocket's pull count and earnings. Stage 3 executes an atomic upsert on the creator's wallet, increasing their internal ledger balance. If this is the creator's very first data pull, a set-on-insert database operator automatically initializes their wallet with the correct currency and zeroes out their payout fields. By restricting these updates to asynchronous atomic operators, the system guarantees accurate ledger accounting without ever locking the database from incoming read requests. Tracking a fraction of a cent is different from actually depositing it into a bank account. Traditional payment processors like Stripe have fixed transaction fees that would instantly consume a micropayment. The fourth stage introduces sub-threshold aggregation, evaluating the creator's balance against a minimum payout threshold. If below $1, the transfer is halted, recording funds as pending cents. Once subsequent polls push the total over the threshold, the system initiates a single cost-effective transfer. This aggregation logic successfully bridges the gap between the microscopic value of a single AI context poll and the fixed costs of global financial rails, making micropayments economically viable for individual creators. This design relies on strict exception safety. If a payment API goes down or a ledger write times out, the failure is isolated. Because the entire metering pipeline operates asynchronously on the event loop, those back-end failures can never propagate up the stack to interrupt the AI agent's hot path. The result is a unified architecture that serves data to autonomous models in under 30 milliseconds while guaranteeing accurate atomic microtransaction accounting. This replaces the binary all-or-nothing control of standard robots.txt files with a dynamic, decentralized marketplace where individual creators set their own retrieval prices. By completely decoupling content delivery from the financial ledger, Metastamp v3 provides the necessary infrastructure for a frictionless, machine-to-machine data licensing economy.